Alright, today we are going to be talking about some algebraic properties that you have already learned in algebra and in pre-algebra, but we're just going to review them for geometry because they are really good and often do coincide with proofs or postulates that you will be learning about later on. Okay, so we have right up at the top in geometry, you accept postulates and properties as true. You use deductive reasoning to prove other statements. Some of the properties that you accept as true are the properties of equality from algebra. They are listed below in the terms of any numbers A, B, and C. So what that means is that as I go through these properties, instead of there being numbers, they're just going to use the variables A, B, and C. Okay, so the first property we have is the addition property. And the addition property just says that if A equals B, then A plus C will equal B plus C. So that just means that if A and B were both 2, okay, so then you would have 2 here and 2 here, and let's say that C is 3. Well, we know that 2 plus 3 equals 2 plus 3, okay? Alright, same sort of idea with the subtraction property. If A equals B, then A minus C equals B minus C. Okay? Alright. The multiplication property, very similar, okay? All of these are pretty straightforward. If A equals B, then A times C equals B times C. Alright? And division, if you haven't already guessed, if A equals B, and C is not 0, okay, then A divided by C will equal B divided by C, okay? The trick here is that C cannot equal 0 because any number divided by 0 does not exist, okay? Alright, the next property we have is the reflexive property, And that basically states that if you have A, it also equals A. It's very straightforward, okay? Our next property is the symmetric property, And what we know about symmetry is that things always have to be the same on both sides. So if A equals B, then B equals A. So if 2 equals 3, then 3, or if A equals B, so if 2 equals 2, then 2 equals 2, okay? All right. The transitive property. The transitive property says if A equals B and B equals C, then A must equal C. This is very similar to the idea of the laws of logic we've been working with, especially the law of syllogism, where we were working with if-then statements. The transitive property is something that comes from that, and the law comes from this idea of this property. So if one is equal to the other and that other one is equal to, another one, then those must coincide. All right? Also, the substitution property. If A equals B, then B can replace A in any expression. If you think back to algebra when we were working with our systems of equations, and we would use one equation to substitute part of for another equation. This property is where that comes from. Okay? So we're going to do a real quick example. So we've solved for x and justify each step. Okay? So we're going to take this. We have angle AOC, which is given that that whole measurement equals 139. Now we know that angle AOB and BOC, AOB equals x and BOC equals 2x plus 10. So we're going to go through and we're going to solve it. Our first step our first step is going to be to set these, both of these, and add them together. So we have x plus 2x plus 10 equals 139. All right, and we can justify this idea because we know the angle addition postulate, which we have already previously learned about, says that if I take this angle and I add it to this angle, it will equal this whole angle. Okay? So the justification for that would be the angle addition postulate, which I'm going to type here. All right. All right. Our next step would be to simplify. Okay, so we have x plus 2x. So we would do 3x plus 10 equals 139. All right, and the justification of that particular one is actually just simplifying. Okay, so we're just doing the problem, we're just simplifying. Okay, all right. The next step would just be to solve it. So we would use the subtraction property of equality to subtract 10 from both sides. Okay, so then we would have 3x equals 129. All right, and we could justify that using the subtraction prop of equality. All right. Okay, and now our next step, we know that our next step is going to be to divide. So I'm just going to come down here and say the division prop of equality. Okay, so in this case, I would divide both sides by 3. And x is going to equal 129 divided by 3, which is 43. All right. So basically what we're doing is we're just taking a problem, we're solving it, and we're justifying each of our steps that we're doing using a different property from algebra. Okay? All right, now there are 3 last properties that we're going to be talking about today. And these properties you've seen before, but we're going to take them and apply them to geometry ideas. So the first one is the reflexive property of equality. And for segment length, basically what they're saying is that for any segment AB, AB is going to equal AB. Same with the angle measurement. For any angle A, measurement of angle A is going to equal the measurement of angle A, which is the same idea as if A equals B, then A equals B. Okay? So the symmetric property of equality, like segment length, says for any segments AB and CD, if AB equals CD, then CD will equal AB. Okay? Alright, angle measurement, same sort of idea. And then the transitive property. If we have for any segments A, B, C, D, and E, F, if AB is going to equal CD and CD equals EF, then using the transitive property, we can conclude that AB is going to equal EF. Same idea for the angle measurement. All right, so that pretty much sums up our different properties in algebra. A lot coming at you, but we're going to practice them tomorrow.